Even though there were a lot of technology breakthrough right now in the warehouse industry, parcels are still manually sorted by hands before it can be transported to the customer. But now, UTS has collaborated with Safe & Co. using advanced robotic technology, introducing GoodsClassifier 2021, a simulated environment that allows two robots to separate parcels based on its color.
Regarding safety in our workspace, we have a physical staff here within the supervisor reach. Besides, there is a safety poster for warning of risk and a fire extinguisher in case of fire.
The robot we're using on this project is Denso VS060, a 6-degree of freedom robot. By applying forward kinematics and inward kinematics, we are able to control the robot by setting the position of the end effector or setting the joint configurations. An e-stop button is also included to make sure that the system can stop immediately when an unexpected event occurs. When the system has been stopped working, we will need to action to reactivate the system. To enhance the safety of the system while operating, we also integrate the light curtain sensors into the system. So whenever the obstacle touches to the light curtain sensors, the whole system inside will stop working until there are not any obstacle inside the light curtains.
When the goods arrive at the end location of a conveyor, a camera attached at the end effector of the second robot is used to detect and move the arm to the goods location via visual servoing. We also utilize the camera for image processing. By separating the image taken at the end effector of the drop-off robots into RGB threshold, we can easily pick out the color that the parcel holds and then assign it to the right location.
To have our robots move safely in its environment, we have used different methods to avoid obstacles. In the pickup stage, we use light plate intersection method, allowing the robot to avoid the conveyor side edge where it drops the boxes onto the belt. Particularly, if the expected trajectory is in collision, the robot tries to move up until it can create a collision-free path. In the drop-off stage, assuming there is an obstacle in the robot's working area, we use ellipsoid collision detection to predict if there is collision in its path, allow the robot who is carrying a goods to avoid both environmental and self-collision. Particularly, with different types of collision we define, we enable different robot links ellipsoids so that estimation can be both accurate and time-saving. Regarding the path planning, we have our robot try to avoid collisions and approach the destination. Moreover, in case the robot cannot avoid the obstacle, a warning will be printed out to the user and the whole system will stop accordingly. And from there, the robot will deliver the goods to the destination.
To improve our system, we would like to have an RGBD camera for better image processing, or having a line rail at the bottom of the Denso for better reach. Moreover, we can also change the arm to some bigger arm for better payload, like the UR10 for industrial purposes.
Robotic systems with a fast, accurate, and persistent property can satisfy any production rate improvement need. The demand for robots therefore will be higher, which leads to the market source for robots to be enlarged. Expense for robots and automation system will be reduced.